Looking at this example, it says a talk radio station has 4 telephone lines, and it says if the host is unable to talk during a commercial or whatever, or is talking already to somebody, then the other callers are placed on hold. There's 4 telephone lines, and they're all in use. The others who try to call get a busy signal. The probability that 0, 1, 2, 3, or 4 people will get through is shown in the distribution. So the probability that 0 people get through is 0.18, 1 person gets through is 0.34, so on and so forth. And it would like us to find the variance and standard deviation for this distribution. Why? To let the station know whether they should consider getting more phone lines installed. Remember, anytime we're asked to find the variance and standard deviation, we start by finding the mean. Our formula for mean is the summation of all our x's times our probability of those x's, of those events. So quickly, again, 0 times 0.18 plus 1 times 0.34 plus 2 times 0.23, 2300, if I'm speaking correctly, so on and so forth. And when you were to figure all of this out, it works out to be about 1.59. I'm just going to round it to 1.6, just so it's a little bit easier to understand. So again, it actually would work out to 1.59, close enough for 1.6 for what we're doing. Let's find the variance. Remember, our variance is going to be the summation of all our x's squared times their probabilities, and then subtracting the square of the mean. Rewrite this again with the squared, and we're taking the summation, so we're adding that all together. And I'm sorry this is so sloppy. Hopefully you can kind of understand what's going on. Again, I'm just squaring each of these and multiplying it. I think I got them all. And then subtracting our mean squared. You were to figure that all out, type it into your calculator. However, it works out to be like 3 79/100 minus 1.6 squared, which is 2.56, and we get a variance of 1.23, which if we were to take the standard, or if we were to find the standard deviation, we take the square root of that, and that works out to be about 1.1. So, mean, variance, standard deviation, what does it all mean? Should the station consider getting more phone lines installed? The answer is no. But why is it no? Well, our mean is 1.6. What does that mean? Well, what does the mean mean? Basically, remember, these numbers tell us the probability of that number of callers getting in. So what's a probability of 1.6 callers getting in? Or I'm sorry, on average, 1.6 callers are going to try to get through. No, there's not going to be a 0.6, but remember, these are theoretical. So we're saying on average, we're going to have about 1.6. So between 1 and 2 people trying to get through. The standard deviation is 1.1. We do not know if this is a normal distribution or not. My guess is no. But according to Chebyshev's theorem, and again, don't let Chebyshev stress you out again. But according to Chebyshev's theorem, remember, 75% will fall within 2 standard deviations of our mean. Well, if our mean is 1.6 and we're going to go in 2 standard deviations in either direction, it doesn't really make sense. We're not going to, 2 times this would be 2.2. That's going to put us below 0. That doesn't really make sense. But if we add 2 standard deviations on here, 2.2, that works out to be 2 times this, plus 1.6, we get 3.8. So really most of the people trying to get in, 75% are going to be between 0 and 3.8. We already have 4 phone lines. So it doesn't make much sense to try to add more, because why go through all that money when really the data is spread out between 0 and 4. That's how we can use this stuff in kind of a real life example, if you'll give me that. The focus, though, remember, is standard deviation, variance. It tells how spread out the data is. In this case, it's really not spread out that much, so we don't have to make any decisions based on that should we be the producer of this talk radio show. Know how to find the mean, know how to find the variance, and after that will come with understanding what all this means.